Okay, so I think if I remember from the end of class last time, we had decided we want monsters to to fight. All right, so let's start thinking about what it would take to accomplish that. Um, I'm going to suggest we go ahead and create another scene. So effectively, what we're looking at here is our scene that allows us to walk around our map. Let's go ahead and create a scene that effectively is like our battle scene. Um, so as it stands right now, what we've named our current scene here is sample scene. I'm going to go ahead and rename this if I can click it better. So let's call this rename. Let's call this Dungeon Walk. That's the Dungeon Walk scene. All right, so that's the one we've already made. Now I'm going to go ahead and create a new scene. So right click in there, create somewhere in here. There should be scene, and I'll just uh, create a blank scene. It's fine. And let's call this guy fight scene. Double click on that, and we're back to an empty scene. All right, so very similar to what we ran into when we first started writing our game. So we want this guy to effectively be our uh, the scene we go to when we're uh, after a fight has started. We don't need to worry about right now how a fight begins. Just one way or another, we're going to end up at this scene, and this scene should play out what our fight mechanics should be like. So, if you were ever someone who played one of the old Final Fantasy games, what you ended up having is kind of the monsters on the left, and you had your people on the right, and then you'd have a little menu that let you choose what do I want to do. Go ahead. That would be okay. I'm not sure that we would have to introduce quite a few things in order to get that. I think we can maybe add something like that in later. Um, but I'm thinking we want this to kind of be turn-based to be compatible with where we're going with the current. Okay, well, I don't know if I've played Dragon Quest. All right. Well, so let's create a monster. And we're going to go ahead and say this monster is going to, and of course, the monster is actually, maybe the monster is, um, well, we'll make him a cube. Oh, that's our monster. Um, we could maybe put this on somewhat of um, have some ground and stuff so we can create a 3D plane. We'll call this guy the ground. Not all that important for what we're accomplishing here, but we can get some stuff looking a certain way. So we'll go into materials. Um, I don't know, let's just make things different. So we'll create a material for our battle scene. Let's make this guy, I don't know, orangey. Call this guy battleground. Drag that onto the ground there. Right. And then maybe our monster. Now, if you want to go into the assets and find an actual 3D model of something that looks cool, you can. That's not uh, I'm not going to spend time doing that stuff. You can facelift it later. So we'll call this guy monster material. And we're going to say that our monsters are green. All right, then we need to have our player. on here somewhere because at some point right now as we walk through our dungeon we have this top-down view and we're the player. We're not actually seeing the player on the screen. In this case, maybe let's go ahead and have our player get onto the screen. So I will create a player, and of course the player is a sphere for no good reason. So that's going to be our player. Let's go ahead and make our player material. And let's see what our players. Players are P yellow or something like that. Like green. Let's go with that. Oh, I need to find my player. Oh, there he is. All right. I want that to be different than that. Let's go with pink. Ah, perfect. Player's pink. All right, so we'll zoom out a little bit, position our people the way we want them positioned. They're both about a half step above the or below the ground right now. We'll do that for monster and for our enemy. So at this point in time, they should be, I forgot to bring my mouse, but we should be able to see them kind of around the they're right on the sitting on the surface. All right. So one way or another, we get ourselves to this scene. And now we want to create a scenario where we're going to be attacking each other. All right. So one thing we could do is if we kind of start modeling this after kind of old Dungeons and Dragons, usually when a fight's about to start, there's kind of this a roll for initiative, see who's going to attack who first. All right, so we probably want to create something along those lines. So we're going to go ahead and we're going to use Unity to start generating random numbers. Yeah. Not going to use a who? A speed step. We're going to do I mean, that's effectively what we're doing. We're going to roll the dice and decide who has the better number, and they're going to make the attack. So effectively, we're going back to our idea of our dice class that we wrote previously. So let's go in and look up Unity random numbers. Unity has its own random number generator, which may or may not be anything super special, but presumably it is game quality random number generation. If you didn't want to use their built-in thing, you could also go and look at C Sharp's multiple built-in random number generators, but it looks like we have something called random.range that lives inside of Unity. And let's see if we can find the documentation here for it so we can practice viewing the documentation. This is a bunch of there's the random class. And this is giving us inclusive, max inclusive. Okay, so it looks like random.range. The first value is the smallest value we wanted to generate, including that value. The next value is the highest value, including that value. So this call to it will generate a number between -10 and 10, including the tens. All right, let's test that real quick. So when the scene first launches, maybe we do something similar to what we had on our first scene, where we kind of have this scene manager, the something that can have a mono behavior attached to it that can do the logic for this scene. So I'll go ahead and create a empty game object over here, and we'll call this guy scene manager. All right. Now this guy is not visible. In fact, we can just drag him off the screen here so his arrows and stuff aren't messing with our view. But he's an empty game object. All that exists is a transform. We're going to go ahead and write a script that we can hang off this guy to have him do some of the logic related to what's going on in our scene here. And we'll let that kind of grow as we're going. So let's go into our scripts. And we're going to create a mono behavior script. And let's call this guy fight scene manager. In fact, I'm going to rename my empty object here to be fight scene manager. No great reason, just to make sure we're differentiating between the scene manager from our first scene and the scene manager from this scene. All right, so we have our fight scene manager. We'll go ahead and attach this script to him. Go ahead and open that guy up. So this is our default fight scene manager. What I'm going to go ahead and do is inside of start, let's mess with that random.range a little bit, make sure we're getting values that look like the kinds of values we want to get. All right, so why don't we generate maybe 10 values. And we're going to do, what was it? Console.log. Or just print. I think it's just print on here. Print, and we'll do random.range. Let's do 0 to 20. And this random class looks like it's in system dot, let's see. Oh, it's unclear. So built into the into C#, we have a random class. This is saying it's ambiguous. Are you talking about Unity's game engine.random or are you talking about system.random? Which of the randoms do you actually mean? The quickest way we could probably fix this is if we just say Unity. What was it? Unity game engine? Oh, Unity engine.random. That guy. So we'll specify that the version of random we actually mean is the Unity engine version of that. That error came from the fact that we're importing both system and Unity engine, and each of those guys has a random class. Frankly, they probably both do just about the same thing. So we're just specifying we want to use Unity's version of the random class. We'll call its range. This should give us values between 0 and 20, including 0 and including 20. Let's see what we get from this. Since we didn't do that much searching to get to the actual documentation, it's possible there's multiple versions of range, ones that take floats and ones that take ints. And let's see what we get from saying, give me some values between 0 and 20. So I'll save this. When we run our game here, it's going to run just the scene we currently have loaded. So we don't need to worry about the mechanism by which we get to the scene. We're going to go in and add that later. Let's just make this scene working. I'll go ahead and run this guy. All right, and let me look at my console here. Let's see, we got a 0, a 9, a 14, a 5, a 10, an 18, 0, 12, 7, 11. I think we're in pretty good shape there. Technically never saw a 20, but let's just assume we would get one since we got a 0 out of it. Okay, so that's we have our random number generator. What we can do now is we can roll that random number generator and decide who goes first. And we get to decide what that means. So maybe we roll a number between 0 and 20 or a 1 and 20. In fact, it might be interesting to see if this does actually hit 20. So let's just check that real quick. I'm going to run that up to 1,000 times. We're going to get our number here. I'm going to say if that guy is equal to a 20. You go first. Oh, that was the debug.log I was looking for. Let's see if it looks any different. I'm guessing it just calls print. All right, I'm not actually printing the number here. I'll just potentially generate 1,000 random numbers. Well, I will generate 1,000 random numbers, and I'll just say you go first every single time I see a 20. Just make sure we eventually get a 20 so we know that that's where uh, the fence posts are. Okay, we didn't, which is actually kind of a good thing in this case. So what it is it's inclusive on that first number. We got a 0, but it's exclusive on the 20. So this will give us values between 0 and 19. If we were rolling a 20-sided die, we really want a number between 1 and 20. So we can just add 1 to whatever this guy gave us. So we can have an int roll is equal to that guy plus 1. So that'll roll our dice. Then we can ask the question, maybe if it's less than or equal to 10, the monster goes. If it's greater than 10, you go, something like that. We could just decide. Usually in a regular tabletop Dungeons and Dragons or something, players have dexterity or they have initiative bonuses and that kind of stuff. We're not going to go that far into this. So we're going to go ahead and roll this, and we're going to say if roll is, let's say, less than or equal to 10, print monster goes first, else player goes first. I like it and I hate it at the same time. All right, so launch this again, make sure it's going through that logic correctly. So if we get a 1 to 10 inclusive, monster will go first. If we get an 11 to 20, the player goes first. Call that good enough. It's a coin flip, if you will. All right, player's going to go first there. Go ahead and run it again. Just see if the monster goes first the next time. Still player. Let's just make sure the monster eventually goes. Monster goes first. Okay, so we got that part out of the way. So now we know who's going to go first, at least from an if statement perspective. So now we got to decide, what does it mean to go? So we have to have kind of our attack. So rather than building this all into the game object, we imagine that, we might be creating battles throughout our game in multiple cases. So every single time there's a fight, that's like kind of an instance of a fight, right? Two objects run into each other. They decide, hey, we're going to throw down, and so a brand new fight breaks out. So we can go ahead and create an object that governs our fights. So let's go ahead and do that. Go into Unity here to go back to my scripts. Now, remember, in our normal scripts folder here, we've put all our mono behaviors at the top level. These are the guys that hang off of game objects that play by the rules of, hey, you have an opportunity to do something every single frame, all that stuff. And inside of our objects folder, we've put kind of our plain Jane C# objects in here that are meant to represent things like a room, a player, an exit, those types of things. So if we want something that's going to govern a fight, this is going to be a normal C# object. All right, so I'll go ahead and create. Our option is a mono behavior script. Let's call this guy a fight. I'll double click on this. It's going to take us into this guy, and we'll start gutting it. So we'll make it no longer a mono behavior. So now it instantiates from, or it inherits from object. Starts no longer a thing, updates no longer a thing. We're going to have our constructor for this guy. All right. Actually, we'll be able to see something here just because of the way it's written. So inside of fight here, I'm going to go ahead. Why is it indenting more than that?
If you're not indenting, the public fight is something that's left.
Oh, it didn't fully indent. All right, thank you. All right, so this is our constructor, normal constructor, just like our constructors in Java. What I'm going to do here is I'm going to go ahead and I'm just going to, well, first of all, notice we don't see a print in here. I think we have a debug.log that came from Unity Engine. And what we'll go ahead and do is we're going to say int roll is equal to random.range 0 to 20 plus 1. It's beautiful. It gives us all of our logic there. So we'll just do that. So notice in this case, we didn't have to say unity engine.random.range. We just said random.range and it's fine with it. Why? Because we're only bringing in Unity Engine up here. We're not using the system namespace like we had in the other thing. I don't know what we were using system for in the other thing, but we see that the issue was that there was confusion over which version of random you wanted to use because we had access to two different ones through two different namespaces. So you could make the argument that, you know what, I'm going to go ahead and I'm going to say Unity Engine dot in front of this anyways, just to protect myself in the future if I end up importing or bringing in the system library that I don't have confusion here, although it would probably yell at me and I can come back and fix it. Yeah.
So is it the same system for Java?
Well, it would be the C Sharp's version of that. So if we look at C Sharp system namespace, take us in here. Here's all the classes that live inside of that guy. So there's a zillion different ones. As I'm looking at it here, I would say this likely is similar to Java's java.lang, which inside of java.lang has a class called system. So the system namespace is the core C# language is how I'm interpreting it here. But we see as you flip through here, there's a zillion different things in here. Several collection things. Oh, here's something we haven't seen in a while. Structs were brought back in C#. Yeah. Oh, this is nothing. You can almost see the icons on these. Yeah, sometimes I get hungry. I spend a lot of time coding. But this is the only class I lecture in. Well, I set my schedule. I only want to teach coding. Otherwise, I wouldn't be on cruise ships. Coding at the bar. Yeah, it's a mental illness when programming is just your hobby and you sit there and write it and it's fun. All right. So I mean, the reason I'm going down some of those paths is these are things you're going to run into. These are the normal kinds of bugs that, and it just goes way back to coding one. When when we first started a program, I said just get a hello world program and run it. Make sure all your everything is zigging when it's supposed to zig and it's zagging when it's supposed to zag. Because if you can't trust your current setup, then everything else that comes after that's just going to be bug ridden. All right, so we probably didn't need to do this here. If I leave that out and later on I need to use something from system, this just become an error. I would highlight over it, would say, hey, I don't know which random you're talking about, and we fix it then. So it's not the end of the world, but just understand that's where that comes from. This isn't like a programming memorization thing. One of the things you need to be able to do as a programmer, in fact, a more important skill is the debugging skill. And something that programmers tend to do is when they see the little red squiggly, they tend to just start changing things rather than reading what the error says. A lot of times it's something fairly obvious, but a lot of times those errors can be ambiguous to read. In fact, I might even say that is an excellent use of AI tools like ChatGPT, where you can just highlight whatever the error is that maybe you're struggling reading, pop it in there, press enter, and just see what it says. It'll say, oh, it looks like you have a problem with this. These are some things to check for. Over time, you'll get better at reading those things, but that's a very good use for it. And I'm guessing you could probably even do that in here. Just right click and say, ask Copilot or something, you know, but whatever. Okay. So inside here, we can create, we have this class called fight. We're going to go ahead and do our role. It'll decide what happens here. I'm going to go back to my fight scene manager. Inside of start, I'm going to gut that because we've effectively already written it in the other thing. Let's see what this guy thinks I want to do with nothing. Okay. So we're going to go ahead and create a fight F is equal to a new fight. So when this scene launches, our fight scene manager will spin up. His mono behavior will spin up, which calls his start function. His start function is going to create an instance of fight. What does fight say to do during its constructor? It says roll the dice, spit out to the console who goes first. That's fine. So let's make sure effectively no new logic, just the mechanism by which we're getting to it has now shifted a little bit. All right, so let's make sure this guy's doing what we want it to do. We're going to be just looking at our console here. Looks like monster goes first in this case. So it got to where we wanted it to go. All right. So let's focus in now on our fight class here, because this is going to be the guy who governs our fights for us. Good.
Is fight like core or
Core is a singleton. So core was a place that, and hint, hint, you're going to find core quite helpful when you're moving from one scene to another and you need things to be shared between the scenes. So core is a singleton, meaning it's a place you can put stuff that exists throughout your application. That's why everything in there is static. Fight is a normal object, just like room is, just like player is. We're going to use the fight object to represent an instance of a fight, where we presume that as we play our game over an hour, we might run into many fights. So we create 40, 50 different instances of fight over time, but each individual one represents the stuff that happened with the fight. There'll probably be a fight between the player and some monster that's visually represented through a game object, that kind of stuff. But we imagine having multiple instances of fight. So it's more like room than it is like core. Core is our local database. We can almost think of it like that. All right. Now, when we decide who goes first here, we can make that decision in the constructor, but we have to have some way of, of dealing with this. If you remember back to, I think we had called the class Deathmatch a long time ago, where we kind of had, our player and our monster in there, and depending on who was first, we had an attacker and a defender, and they would roll dice against each other. So this is the guy that's going to govern that fight. So maybe in the constructor, we decide who's going to go first, but we have to. So now we have visually represented who's going to go first, either by just saying monster or saying player goes first. But now we need to make the logic add up to that. So up top here, before we get um, game objects and some other things involved, let's kind of create the logic of our fight. So what we're going to have is an attacker and a defender. All right. And our attacker and our defender are going to be, well, one of them is going to be our player. Another one is going to be the monster or whatever. But we need to have this core idea of an inhabitant. Things that might exist in our dungeon. A player is something that inhabits our dungeon. Our monster is something that inhabits our dungeon. Remember that keyword abstract from a while ago? What does the abstract keyword do? What is the Why would we use the abstract keyword in object-oriented programming? Has to do with the inheritance model. So if we're building something with the sole purpose of other classes building on top of it, we make that initial class abstract. All right, so we're going to go ahead and create an abstract class called inhabitant because it will be inhabitants that fight each other in our dungeon. Anything that inhabits, we don't have to call it inhabitant. You can call it whatever you want, but I don't know. Does somebody have a better name for our dungeon than an inhabitant for a generic entity that wanders the dungeons? Go with inhabitant. That should be a funny one though, because I'm particularly bad at spelling that one. So, so let's go ahead and create that class. Go back into our project here because this is going to be another plain Jane class, not a mono behavior. Just going to create. My option is to create a mono behavior inside of Unity. So it started off as that. We're going to call this guy an inhabitant. Open it up. We'll go ahead and unmono behavior it. We'll dump these other things. Make it an abstract class. Everything we have on the screen right now might as well be Java, right? So they're the same languages. That's another thing I'd encourage you to do once you get over the initial hump of being intimidated by coding. When you start working on your own projects, purposely try to shift between languages. Don't just pick a language you're comfortable with and keep coding in that. Convince yourself that all the languages are the same. Challenge yourself to say, oh, here's a brand new language, Rust or something that just came out. Start messing with it. And within a couple hours, you're saying like, oh, this is this. I've seen this 50 different times from different languages. That'll convince you that the skill you're building is the programming skill, not the language skill. All right, so we made this guy abstract, and what that effectively says is we are not allowed to, if I go back into fight here, I can't come in here and say inhabitant I is equal to new inhabitant. I'm not allowed to do that. If I highlight over this guy, cannot create an instance of the abstract type inhabitant, which is what we just said. That's what abstract does. Okay, so we're building inhabitant to be the kind of the core components of whatever every inhabitant of our game might have. So maybe it's hit points and armor class for a simple fight. All right. So we're gonna say inside. Oh, let me dump that here real quick. So inside of inhabitant here, we're going to say, you know what? Every inhabitant needs to have, like I said, hit points and armor class. Let's not deal with strength and all these other things yet because we're building the fist fight effectively. All right, so we'll have a private int HP for hit points. Notice it already put in our max hit points. If you remember how we used that from before, is we're keeping track of however many hit points we potentially have, and we also need to know how beat up are we currently. Well, so as you get hit, your hit points are going to lower, but you still need to remember where you started from in case you have a healing potion or something. You need to get back to that. So we're keeping track of two different things here. And then let's do a private int AC for armor class. I guess we can do a damage too. I guess we can say all inhabitants have names. All right, so we're going to say this is kind of the core components of an inhabitant. They all can get hurt. They all can hurt somebody, and they all have some level of defense through their armor class. All right, so we'll go ahead and build our constructor for inhabitant. Now, tell me, if a class is abstract, which means we can never create instances of it, why would we need a constructor? Let's start with, oh, go ahead.
Oh, like if you pick a child of that class, they can inherit constructor.
Yeah. Just because we can't directly create an instance of inhabitant does not mean that we will never have instances of inhabitant. The instances of inhabitant will exist as um, part of the behavior of children of inhabitant. So if we create a monster would first generate its inhabitedness. Could be a word. Okay, its inhabitedness, which would call this constructor. We just can't call this constructor directly. We can't directly create an instance. All right, so we'll create a public inhabitant. I'm just going to have this guy take in a name. All right, and it'll go ahead and set this dot name equal to name. And inside here, we'll go ahead and spin up the other variables. All right, so for hit points and max hit points is going to be the maximum number of hit points it ever can have. And we probably want to set current hit points to that as well. In fact, I kind of like maybe calling this guy cur HP for how many hit points do you currently have after you've, mid-fight. So we're going to go ahead and use our random number generator here. We have Unity Engine, so random.range is the only guy in town, right? So for hit points, I mean, we should just arbitrarily pick stuff. Let's say hit points can be something between, what, 30 and 50, something like that. All right, so let's go ahead and say this dot max HP is equal to random dot range. All right, so I want to have a value between 30 and 50. So if I say, give me a value between, oh, this is actually going to be very convenient for that. We don't have to do any of the mod magic, right? We can say, here's the minimum and maximum. If you remember back in Java when we did the random class and used the next int function, it gave us a value between negative 2.1 billion and positive 2.1 billion. We then had to make it positive, and then we had to whittle it down to our range. So we'll get that. We'll set current hit points equal to max hit points. Let's see what it thinks we should have as our random range for armor class. It thinks armor class should be between 10 and 20. Seems reasonable enough, I guess. So we'll hit tab on that. How hard does our guy hit here? This is effectively his fist strength. We might want to roll that every single time we actually do an attack rather than just having him have a set fist power. So we won't even put anything for that. So we have our armor class, we have our name, we have our current max hit points, damage. We actually probably don't even need to keep track of that if we are going to generate it in real time. So we can go ahead and even just dump that variable. All right, so when we create an instance of inhabitant, it's going to go ahead and set its name, set its hit points, all this other stuff. Now, since we're making this abstract, do you think these guys are going to remain private? Or what are they going to shift to? Protected. Because our monster class probably is going to want to be able to check in on his own hit points, right? So if our monster class extends inhabitant, so we'll go ahead and create our monster class here. So create mono behavior, monster. This is kind of our workflow. Every single time we need a new script, make a mono behavior, then demono behavior it to give us our normal script. And in this case, we want this guy to extend inhabitant. So we're seeing a difference between Java and C# in that instead of writing the word extends, we just put a little colon here, which is actually something somewhat stolen from C++. Remember in C++ you had to have 2 colons? I think you saw that just a little bit because didn't we pivot to Java before we started doing classes in C++? But I think at some point, probably with IO stream, probably IO stream C out. You had the two double colons. Yeah, for the standard, right? So it kind of stole from old syntax. But this is saying monster inhabits from or extends inhabitant. If I hover over this, it's going to be screaming at me saying, no argument given for name to the inhabitant's constructor. We wrote inhabitant. Inhabitants have to be built. If we're going to say a monster is an inhabitant and potentially more, at some point that inhabitant constructor needs to be called. Since we didn't directly call it here ourselves, C Sharp's trying to figure out how do I make the inhabitedness of this monster. Usually we're going to do it ourselves. So we'll go ahead and say public monster. We'll probably want to go ahead and have our monster also take in a name. Now, one nice thing, I think we had seen this one other time, but I'll go ahead and re-explain it. If we were in Java, what we would have done here is we would have said super name. Growling at your laptop is also quite therapeutic. Never works, but it's okay. So if we were in Java, that's what we would have written here to call. Remember, super is our instance of our parent. Where in C sharp, it's we use the keyword base, but specifically C sharp has this special syntax that allows us to call upon our parent's constructor as part of our constructor here. We're saying our, and remember back in Java, when we if we were to call our parents constructor, it had to be the very first thing that occurred in our constructor. So this is no different than Java was. It just happens to happen one line above. It's not the first line inside the curly brace. It happens. It's just part of the header here. But this is calling inhabitants constructor, passing it its name because that's what inhabitants constructor wants. Make sense? All right, so little bit of a twist and turn from Java, but basically the same thing. All right, so now at this point in time, our monster already has hit points, has current hit points, has max hit points. It has an armor class. He can't get to any of those things currently because if we go in here right now and we do something like public int get cur HP, and with the expectation that we were going to return this dot cur HP, this guy's currently screaming at us. Before we even hover over this, why is it screaming at us? Why does it not like us trying to access this instance of monsters variable called cur HP? This instance of monster is an inhabitant. Here's what inhabitants look like. Why can I not access cur HP? We haven't hovered over the red squiggly yet, but what do you think? Yeah, because it's still private. Private says you can only access this variable inside of this exact class. If we want it to be accessible outside of this class, we need to make that protected, but we don't want it to just be accessible anywhere. We want to make it accessible to our children. So now if we go back to monster here, you see he's already calmed down. He's gone off of red. He's cool with this now because it's protected, yet all the other ones are still private. So we probably want to go and patch those up real quick. So we'll just copy that protected word there. We'll say max HP also protected, armor class also protected, name also protected. That's actually an interesting thing there because as we just had it written before, when name is private inside monster, we have access to the name right here. We were able to send the name in to our parents' constructor, but we would not have been able to get it back out. If I said get name, so if we had a public string get name, return this dot name, it's yelling at me, even though this variable was set right here. We had it. We sent it into our parent, the abstract class inhabitant, and lost access to it because it's private inside of that class. But if we go and make that variable available to the children, this guy will be happy again. And now we have access to the current hit points and the name and, whatever. Okay. So what this means is in our constructor as of right now, we actually don't need to do any extra work. The constructor had to exist. We had to get the name for this monster because that's what our parent required us to have to build. But as of right now, as our current imagination of what a monster is relative to an inhabitant, we have everything we need. We'll probably add to monster at some point. Maybe monsters have another special kind of psychic attack or something like that, but this should be good enough for right now. Let me go ahead and bring up player. So here's our player class here. I can go ahead and make player also an inhabitant. So he'll get all those things. We no longer need to get the name of we no longer need to locally store the name of the player because the name of the player is now going to be trapped in the inhabitantness of the player. So I can dump that. And when I build a player, go ahead and pass that name on to inhabitant. The rest of the stuff is going to remain the same. So that's all I had to do at this point to make our player an inhabitant as well as our monster inhabitant. All right. So now we have inhabitants wandering around our dungeon. And what we want to do is we want to have a fight be between two inhabitants, the attacker and the defender. So inside fight, we could say private, inhabitant, attacker, private, inhabitant, defender. And depending on who goes first or last here, we want to go ahead and build our monster and our player. Well, we already have access to our player, right? Through core.player. Player already exists. And now he has hit points and stuff. Even though we didn't go in and make many changes to player at all, by making him now an inhabitant, that player now has hit points and all that jazz. All right. So what we want to do is we're going to have a public void start fight. This guy should have the attacker and defender fight each other until one of them dies. The attacker and defender should alternate between called each fight round. And the one who goes first was determined in the constructor. All right, so for this assignment, you're not actually going to be making anything on the screen move. So what you would do is inside of your fight scene manager, you would create a fight and then say F dot start fight. And everything else would just be out at the command prompt at the console. You just print out the attacks back and forth, just proving that your back and forth attacks are doing what they're supposed to do. If you want inspiration for this is going to be basically the same thing we wrote for Deathmatch. All right. So what we want to have for next class is have a working fight thing unrelated to Unity. It just happens to be that you're testing it in Unity. And then we'll attach our players and stuff to it next time so that we can see their hit points going down and that kind of stuff. All right. So I'll push this code up there. I'll give you the starting point for the code what I have here. So bring your code up to speed and implement this for Friday. Questions, comments, concerns, bribes? All right. I'll see everybody on Friday.